Question number 7. What is the full electron configuration of phosphorus 3-? So first let's find the electron configuration of just a ground state phosphorus ion atom. And starting from hydrogen, we're going to move left to right across the periodic table, writing the row number and then the block letter. So starting from hydrogen, we write 1s and then 2, which signifies that there are 2 electrons in this orbital. And then moving down to the next row is 2s2. Moving across to the p block, we write 2p6. So this 6 goes from boron to neon. And then we just do the same thing until we get to our phosphorus. So now to the next row is 3s2, and then 3p. And then we just count out all the electrons up to the phosphorus. So we count 1, 2, 3. So it just ends in 3p3. If phosphorus had a 3 plus charge, I believe, or was it 3 minus? Okay, so it was 3 minus. So if we have phosphorus 3 minus, that means it gained 3 negatively charged electrons. So our new electron configuration would start off the same. 3s2. And if we were to add 3 electrons, 1, 2, 3, we get 3p6. So now this tells us that this phosphorus that has 3 electrons added to it now has the same electron configuration as argon. On the other hand, when it was in its ground state, if we were to write the shorthand configuration, we would write the noble gas that came before it, which was neon. So we write neon in square brackets, and then we just continue on with the rest of the electron configuration. 3s2, and then 3p3. So originally it had the following configuration, but once it gained 3 electrons, it had the same electron configuration as argon, which is a noble gas. So the junior tutor said 1s2, 2s2, 2p6, 3s2, 3p6, which is correct. And then they explained why. An element's electron configuration is a numeric representation of its electron orbitals, which are regions around an atom's nucleus where electrons are likely to be located. It tells us how many electron orbitals an atom has, as well as the number of electrons in each of its orbitals. It shows the distribution of electrons of an atom. The area where the electrons orbit is called an electron shell. As an atom or molecule gains electrons, they fill different orbital sets according to a specific order. Each set of orbitals contain an even number of electrons when full, and the sets of orbitals are the s, which contains a single orbital, which can hold a max of 2 electrons. P orbital contains 3 and can hold a total of 6. The d orbital contains 5 and can hold 10 electrons. And the f orbital contains 7 and can hold 14 electrons. When writing the configuration, find the element's atomic number, and each atom has a specific number of electrons associated with it. So if it's neutral, then we have the same number of electrons as we do protons. Find it on the periodic table, determine the atom's charge, write the electron configuration notation. So they display the number of electrons in an atom as well as the number of electrons in each orbital, and they should be written in sequence, with the number of electrons in each orbital written in superscript to the orbital name. And then fill in the orbitals according to the number of electrons in the atom. Fill in the electron orbitals starting with the lowest energy, and then following Aufbau principle, Pauli exclusion principle, and Hund's rule, the phosphorus atom has 15 electrons, and the phosphorus ion has 18. The first two will go into 1s, the next two into 2s, the next 6 into 2p, and the next 2 and 3s. The last 6 go to the 3p. So this solution is correct.